So just remember, this is what we were doing. That first thing, if the substance likes to lose electrons, the potential would become negative. If the substance likes to gain electrons, the potential would become positive. Um, so we did three types of electrodes, and you should know how to draw those electrodes. Then we started talking about that when you try to measure electrode potential, you always measure it against a certain reference point. Okay, that's what you do. You always have a reference point. Uh, any measurement requires a reference point. Without reference point, nothing would make sense. Uh, and that reference point is a standard hydrogen electrode. So every electrode that we measured was supposed to be measured, its voltage was supposed to be measured in reference to the standard hydrogen electrode. Is this clear?
Yes.
So I told you that if you have a chromium ion electrode, you're going to connect it with the voltmeter to a standard hydrogen electrode. The standard hydrogen electrode would by default be your 0 volts, uh, and the voltage that you get it would be of this electrode. You're going to assign it to this electrode. Now, the next thing, we left it at this point that all the electrodes that we have drawn so far, all the electrodes that had this ground over here, this ground is a reference electrode, and that's your standard hydrogen electrode. So when you're being asked to draw the complete diagram, you're not going to draw this ground over here. TK, remember not to draw this. There's going to be a standard hydrogen electrode that has to be drawn at this point. Now, this is where we left off. Now, I told you that the last thing that we talked about was that I told you that this is known as an electrochemical cell. Why is it a cell? Because it's composed of two things. It's composed of uh, it's made up of two electrodes. So when you connect any two electrodes together, because of the potential difference, a current is going to be produced. I mean, you know basic physics that if there's a potential difference, the electrons always flow from the lower potential to the higher potential. Remember this. So, which is why it's referred to as a cell because it's going to produce electricity. Electrons flow from lower potential, or we can call it lower E naught, and then towards higher E naught. Towards higher E naught, always. And that's one thing. Electrons flow from low E naught to high E naught, two electrodes together. There was one more thing that I had to talk about was that in a cell, chemical energy gets converted into electrical energy. So because of whatever chemical reaction that's happening in this electrode or in this electrode, whatever is going on over here, there is a resultant potential difference that is created, and electrons they start to flow. So chemical energy gets converted into electrical energy. So that is precisely what a cell does. Um, so in this case, chromium had a voltage of minus 0.91 volts across it. This was your 0 volts. So again, electrons flow from the lower to the higher. And remember, I'm stressing this over and over again. Don't focus on the negative signs. Don't focus on the positive signs. The plus and minus are kind of irrelevant. Always remember there's a higher potential and there's a lower potential. So electrons always flow towards the higher potential. The higher potential is the one that's going to be referred to as your positive, and the lower potential is the one that's going to be referred to as your negative. So this is what you get. And I told you that a salt bridge is very necessary because otherwise it's very important to complete the circuit. Otherwise, a voltage will not appear on this voltmeter over here. The potential difference over here right now at the moment is minus 0.91 volts. That's the value that's going to appear. on this voltmeter over here at the moment. Uh, but also remember that without the salt bridge, no reaction is possible. Nothing would be possible. And I'm going to explain what the salt bridge would do. ठीक है? So last time we didn't talk about the salt bridge, and details are not very important about this salt bridge. Just remember, salt bridge contains ions. It contains positive and negative ions. Now the problem is, now listen to this very very carefully. ठीक है? What I'm going to try and say now, listen to this very very carefully. So when you connect two electrodes together, right? So you've got this hydrogen electrode and you've got this chromium electrode. Uh, Initially, when it was alone, it had reached equilibrium. Like chromium was losing electrons to form chromium 2 plus, and chromium 2 plus was gaining electrons to form chromium back again. And just let me confirm whether this is minus 0.91 volts or not. Where's the data booklet? Just a second. Chromium, the value of chromium, what's the potential? So CR minus point, ठीक है, that is minus 0.91. Acha, is this clear so far up till this point? Everyone, is this clear?
Yeah.
Yeah.
Acha, so okay. So what's the purpose of the salt bridge and what's going to happen? What's going to happen is that I told you one thing. I told you that the lower potential one likes to lose electrons, right? And I also told you that the basic concept is that the higher E naught, or the one that has a higher potential or more positive one, that likes to gain electron. So this is exactly what's happening. Where are the electrons traveling towards? The electrons are traveling towards this electrode over here. Uh, why? Because it likes to gain electrons. So as more and more electrons travel to this side, there's going to be more electrons over here. Now think of it in terms of equilibrium. Focus on this equilibrium over here. So because of the potential difference that exists, electrons, they start to move from the lower potential side to the higher potential side. So over here you get more and more electrons. The electrons constantly coming towards this electrode. So can anyone explain to me what would happen? Where would the equilibrium shift if there are more electrons coming towards this electrode? Like you have more electrons, where would the equilibrium shift? Towards the right or towards the left?
Right.
Okay, so the equilibrium would shift towards it's going to shift towards the right. So it's going to move in the forward direction. Is this clear? Bhaskar, Zahir, Rubab, is this clear, Nabila?
Yes, sir.
Okay, so
Sir, can you explain it again?
I'm going to explain. I mean, I just told you that. Just a second. So I'm going to explain this again. I had a hydrogen electrode and I connected it with a chromium electrode, right? The hydrogen electrode had a potential of 0 volts. That's your reference electrode, and your chromium electrode had a potential of minus 0.91 volts. So basic physics, what's going to happen? As soon as you connect two things with different potentials together, the electrons from this side would start traveling to the other side. Zaib, is this clear?
Yeah.
So now, previously, there was a reversible reaction going on. Both forward and backward reaction were happening, and the amount of electrons remained constant on this electrode. The potential on this electrode remained constant. It did not change. Zaib, is that clear as well?
Yeah.
Achha, but now the equilibrium is going to be affected. Why? Because all of a sudden you connected this electrode with this electrode over here. So the electrons from this electrode, the lower potential one, would start to travel to the other side. So all of a sudden on this electrode, what would happen to the number of electrons? They're going to increase, right?
Yeah.
So if the number of electrons in this equilibrium they start to increase, where would the equilibrium shift? It's going to shift to the right, right?
Oh, okay.
ठीक है?
Okay.
Le principle was that if you try to increase something, it would try to decrease something. The same thing. So is this clear?
Yes, sir.
Yes.
And this is exactly the rule that we made initially. That higher E naught likes to gain electrons, and this is exactly what's happening now. Remember this: when you connect two electrodes together, now there is no reversible reaction. Now there is no equilibrium. This is moving in the forward direction. It's not going in the backward direction. There are electrons coming from that side, and it would there would be constantly electrons coming to this side. The amount of electrons would increase, and the equilibrium would start to shift to the right. So now the equilibrium is no longer existing. It's a forward reaction only. So is this idea clear?
Yeah.
Yeah.
Achha, what about this side? The opposite would happen to this side. Because it was the lower potential, the electrons from this side started traveling to the other side. So what would happen to the quantity of electrons? What would happen to the quantity of electrons? Just one second. So what's going to happen to the quantity of electrons in this equilibrium? They are going to decrease because where are all the electrons going? They're going towards they're attracted to the higher potential side. So the amount of electrons on this electrode would decrease. So if the number of electrons decrease, what does equilibrium state? Le Chatelet principle. It states that if the electrons decrease, the equilibrium would try to make more electrons, and which is why the equilibrium would shift in the backward direction. Is this clear?
Yes.
TK, is this clear to everyone?
Yes.
Yes.
Okay, so remember this equilibrium thing would only exist if the electrode is isolated, if it's completely disconnected from everything else, then it will be at equilibrium. But as soon as you connect it with some other electrode, a current would start flowing. One side would start to lose electrons, and it's the electrons flow from the lower potential to the higher potential side. So the amount of electrons over here would start increasing, so the equilibrium automatically shift. It will start shifting to the right. It will start gaining electrons. And the other side over here, the number of electrons on this electrode would decrease because they're all getting attracted to the higher potential side. So if the number of electrons decrease, the equilibrium, Le Chatelet principle states that the equilibrium would try to make more electrons. So it's going to shift in the backward direction. So the thing is, what you just have to remember is higher E naught gains electrons, lower E naught loses electrons. So forget that they were ever at equilibrium. Now they're no longer at equilibrium. So now what the reaction that's happening is, let me write the reaction. Now you have a reaction going on. Now it's no longer in equilibrium. You have a reaction that's happening. So over here, what's happening is, so I'm going to ignore the reversible sign now. What's happening is that there is 2H plus 1 ions. They're constantly gaining electrons to form H2 gas molecules, right? So this is the reaction that's happening on this side. And on the other side, the reaction that's happening is the reverse. It's in the backward direction. It's chromium that's losing electrons to form chromium 2 plus. So I'm going to write it. So it's chromium, which is constantly losing electrons to form chromium 2 plus and producing 2 electrons. Now, I said now it's no longer reversible. Okay, I've just straightened the equation. It's chromium that's losing electrons to form chromium 2 plus and 2 electrons. Chromium losing electrons to form these two things. So is this clear?
Yes.
Yes.
Yes, sir.
Achha, so uh, so the basic idea is that once you connect two electrodes together, a reaction starts. Things are no longer at equilibrium. The equilibrium is disturbed, and a reaction starts. One side starts to gain electrons. Who gains electrons? The higher potential side. I mean, you don't even have to think about it in terms of equilibrium. Just focus on the potential. If it's the higher potential, it would gain electron. It's going to move in the forward direction. And if it's a lower potential, it's going to lose electrons. It's going to move in the backward direction. And that's your reaction. These are your two half reactions. I mean, this one is your reduction reaction. So one of them is your, this is reduction happening. And this reaction over here is your oxidation reaction. So there's reduction happening and there is oxidation that's going on. Uh, and another thing that you can do is you can combine the two reactions together. And if you combine the two reactions together, you'll get an overall reaction of what's happening, like the overall cell reaction. If you combine the two reactions together, these are your two half reactions. So I'm just going to do that. What I'm going to do is I'm going to take this equation, but only the equation, just a second. So you can combine the two equations. So that's one. Here is the second one. So I have both equations. And I'm going to combine the two equations together to get the overall reaction. So the overall reaction is, what's the overall reaction? It's going to be you simply add up the reactants. One thing that you should do is make sure that the number of electrons gained and lost are equal. You have to make sure that's equal. I'll just write that down. That make sure. I mean, this is all that we were doing when we were doing balancing equations. So make sure electrons lost and gained they're equal, and you just add up the reactants. What are your reactants and what are your products? So this side over here, those are my reactants. So it's chromium reacting with 2H plus 1, and they're producing what? They're producing chromium 2 plus H2 gas molecule. So you just add up the reactants and you add up the products. So that's my overall reaction now. So by looking at the two half electrodes, I was able to figure out who gains electrons, who loses electrons, and I've figured out a redox reaction. And that's my redox reaction. I've been able to predict what the reaction is going to be if chromium reacts with H plus 1. This would be formed. Chromium 2 plus H2 gas would be given off. Is this clear?
Yeah.
Yes.
Yes, sir.
So you're going to keep things very simple. You've got two electrodes. Higher potential is the one that's going to gain electrons. Lower potential is the one that's going to lose electrons. When you connect two electrodes together, the reactions are no longer at equilibrium. One side has to gain electrons, which is the higher potential side. Electrons would always flow towards it. And the other side, the lower potential side, is the one that loses electrons. And you just sum up the reactants. You get the two half equations, and then you sum up the reactants and the products. I mean, you don't have to do this step, or you can do it directly as well. Like, make sure the number of electrons gained and lost are equal. Add the reactants, so it's going to be chromium and 2H plus 1. Add the products. The products are going to be chromium 2 plus and H2 gas. So you're going to get this. Now, one other thing that you're going to get is it's going to be the voltage over here. What do you think the value of the voltage would suggest? Now, how do you calculate voltage in physics? Like, you have 0 volts over here, minus 0.91 volts over here. So how do you calculate voltage?
The difference.
I think it's the difference, and usually it's the higher potential minus the lower potential, right? So in this case, the higher potential is 0 and the lower potential is minus 0.91. So the voltage that I am going to get is 0 minus 0.91 volts. and this value comes out to be plus 0.91 volts. Now, what does this value indicate? And that's my E naught cell. Uh, let me write this over here. We can do another one. So this is referred to as the E naught of the cell. Because now we're not talking about electrodes, we're talking about a complete cell. So it's higher potential minus lower potential. This gives me 0.91 volts. So the value of the E naught cell, or the value or the potential difference between the two electrodes, what information does this convey? Can you tell me if the voltage is really high, if the potential difference is really high, would there be more electrons flowing or would there be less electrons flowing? Like, would there be more current or less current?
Less current?
If the voltage is high, like a higher voltage,
More current.
more current. Well, it's remember that if you have a higher voltage, that means the electrons would be. What is voltage? Voltage is basically energy per charge. It's energy per coulomb. So the electrons would be more energetic and they would flow much quicker. Okay, so they're going to flow much quicker, which kind of indicates that the reaction is going to be more vigorous. It's going to happen at a much faster rate. So the voltage that's going to appear on the E naught on the cell, that would indicate how fast the reaction is going to be. So if there is zero voltage, like if there is no voltage, like this is, if the voltage difference is potential difference is exactly the same, then obviously no electrons would flow. If the voltage difference, potential difference is really large, then the electrons would flow very fast. Is this clear as well?
Yes.
Yes, sir.
Okay, so remember this, another information that you're going to get is, uh, so that's known as your E naught cell, which is going to be the potential difference between your two. It's going to be the potential difference between your two electrodes. So I'm going to write E naught cell over here. Now your E naught cell, just one second. So E naught cell is your reduction potential minus your oxidation potential. Okay, it's the difference between your two electrodes, which in physics you can just write higher minus lower. Higher E naught minus the lower E naught. Why did I write reduction minus oxidation? Because I just showed you this side is reduction, this side is oxidation. The higher E naught minus the lower E naught. Higher potential minus the lower potential. So technically you're going to call it reduction potential minus the oxidation potential. And remember, larger value indicates more vigorous, more feasible reaction. More vigorous and feasible reaction. If the potential difference is really low, the electrons would flow. They're not going to flow that easily. So the reaction would probably be not that spontaneous. So larger value indicates more vigorous, feasible reaction. The minimum requirement is that the E naught cell must be positive. It must be greater than zero. As long as if it's equal to zero, then it's obviously not a feasible reaction because electrons are not going to flow if there is no potential difference. So it has to be greater than zero for a feasible reaction. Okay, is this point clear to everyone?
Yes.
Ethan, is this clear? Bazga,
Yes, sir.
okay. So So remember, you can connect any of the two electrodes together, and there's going to be they're going to form a cell. There's going to be an electrode which has a higher potential. There's going to be an electrode which has a lower potential. Electrons flow towards the higher potential. The higher potential side would gain electron, and the lower potential side would start to lose electrons. There's going to be oxidation happening, and there's going to be reduction happening, and you can combine the two to form a redox reaction. And the E naught cell value would indicate how fast that reaction would happen. So you'll get an idea of the reaction, and you'll figure out how fast that reaction also happens. Now again, one thing that we have still not done is, what's the point of the salt bridge over here? Why do you need the salt bridge over here? Acha, can any so now we're going to discuss just briefly, TK. You don't have to go into a lot of detail about the salt bridge. So just very, very briefly, why is the salt bridge needed? The first thing, once two electrodes are connected, there is no equilibrium. Chromium would start to lose electrons and would start forming chromium 2 plus ions. So what would happen to the solution over here? What's going to happen to the solution is there's going to be more and more chromium 2 plus ions that are going to be formed. Is this clear?
Yes.
Yes.
Right? I mean, this is the equation that we said. This is the reaction that's going to happen, right? The equilibrium would shift backwards. It's going to produce more and more chromium 2 plus ions. So a lot of chromium 2 plus ions are going to be produced. Now, is this idea clear? So the ions in the solution, they would increase in quantity. So there's an electron over here that's trying to leave, and it's trying to move from the lower potential side to the higher potential side. So what do you think would happen? That if there's a lot of chromium ions and they are positively charged,
They'll start attracting the electron, I guess.
okay, so they're going to start attracting the electron, and the electron would not be able to travel to the other side. Is this idea clear?
Yes.
So which is why the current would not flow in the circuit if this happens. Is this clear, everyone?
Yes, sir.
Okay. So
Yes.
so the point is, immediately as you set up this electrochemical cell, the electrons would stop flowing and the reactions would completely come to a standstill, because if the electrons are not flowing, I mean, H plus 1 would not be able to gain electrons on this side because there are no electrons coming from the other side, because there are too many chromium 2 plus ions in the solution and they're pulling the electrons back. So to make sure that the electrons continue to flow and there's a constant flow of current, you need to get rid of the chromium 2 plus ions, because constantly there's chromium 2 plus ions being produced. So you need to constantly get rid of these chromium 2 plus ions. So what the salt bridge would do is that the salt bridge would act as a diffusion channel. Like what is diffusion? The particles move from a region of higher concentration to a region of lower concentration. So the salt bridge would start attracting or absorbing all the extra chromium 2 plus ions. So all these extra chromium 2 plus ions would get absorbed by the salt bridge. Is this idea clear?
Yes.
Yes.
So now, because if the chromium 2 plus ions concentration increases in solution, they would immediately stop the electron flow. So to complete the circuit, the salt bridge is necessary. Otherwise, no current would be able to flow through the circuit. And no volt. I mean, if there is no current, there's no voltage appearing over here, because there is no electrons flowing. So that's the important point. That's the important role that the salt bridge plays. That it kind of balances the ions. Pretty much the same thing would happen on this side as well. Like, what would happen? There's H plus 1, and they're turning into H2 gas, right? The electrons coming in, and the H plus 1 are turning into H2 gas, right? So, what's happening to all the H plus ions? They're getting used up, right? So, in this case, on the right side, the opposite is happening. That you had a bunch of H plus 1 ions, but all the H plus 1 ions are getting used up. Okay, so they're getting used up. So if you run out of H plus ions, like if the solution is now devoid of any H plus ions, so who's going to gain these electrons? There's no one in the solution that's going to gain electrons. So the salt bridge would be made from a salt that contains H plus ions. So all of a sudden, the H plus ions, because they're gone, they would start diffusing out of the salt bridge. So the quantity of H plus ions would be maintained over here. Is this clear?
Sir, this salt
Yeah.
bridge, will it absorb all chromium ions or just like a couple of them, like a number of them?
No, it depends. It's a diffusion channel, right? Like if you have more chromium ions over here, they would automatically start diffusing into the salt bridge. They would move from a region of higher concentration to a region of lower concentration. And the other side is also true. Like if you run out of H plus ions, then who's going to gain these electrons that are coming over here? So you need a constant supply of H plus ions. So the salt bridge would have a salt or an acid salt that contains H plus ions. The H plus ions would start diffusing out as soon as the solution, the amount of H plus ions in the solution decrease. Is this clear?
Yes, sir.
But at the end of the day, all cells they run out. I mean, this can only happen to a certain extent. Eventually, all cells they usually the battery dies. Why? Because you can only produce that many H plus ions. So the point is, the salt bridge is necessary for completing the circuit. That's one thing that you have to know, and the main purpose of the salt bridge is that it balances out the ions so that the ions don't get disbalanced, and if they either increase in quantity or decrease in quantity, the electron flow would be impeded. It's not going to happen that the electrons would stop flowing. So so this is it. This is your entire electrochemical cell. This is one example of an electrochemical cell. Remember, you can connect any two electrodes together and you can do the same thing. Just remember higher potential, and let me highlight this. Just remember higher potential gains, sorry, lower potential loses electrons, and higher potential would start to gain electrons. So we can quickly construct another electro. I mean, this one is too complicated. This one is too easy. Let's work with this one. So we can I can copy this electrode and I can connect it with any other random electrode. Like I have all the potentials. So I'm going to pick one electrode, this one. And so now it's not necessary that I need to connect it with a hydrogen electrode. Like to make a cell, I can connect it with any electrode. So so over here, I'm going to do just that. I'm going to just remove this. And I'm going to connect this electrode. Now the voltage of this particular electrode is given as in the periodic table. It's not the periodic table, in the data booklet. The Cl2 one is given as 1.36 volts. But at the moment it's in equilibrium. Like both forward and backward reaction are happening at the same time. But once I connect it with another electrode, it's no longer going to be at equilibrium. So this is it. And let's pick any electrode. Uh, let's pick this electrode. So I'm going to connect it with this electrode. The voltage is also given as 0.34 volts. So here's my other electrode. Here, let me. You can rub this off. And I'm going to connect this electrode with this other electrode. So I've connected the two electrodes together with a voltmeter, and we can This one has a voltage of 0.36 volts. Okay, we can ignore this. Okay, not 0.36, it's 0.34 actually. Acha, can anyone tell me, and there's going to be a solve bridge. Remember, there's going to be a solve bridge. If you don't draw, you lose marks. So let's say this is R. This is a solve bridge. Can anyone tell me where would the electrons flow? This side to this side or this side to this side?
Right to left.
Okay, so they're going to move towards the higher potential. As soon as I connect them together, now there's a current flowing. And now there is no equilibrium. Remember, the higher potential one is the one that's going to gain electrons. Okay, that's your higher potential one. And the lower potential one would be the one that would be losing electrons, right? So you have a reaction going on now. There's a redox reaction that's happening, and you can make an overall reaction. Make sure the number of electrons gained and lost are equal. So who are your reactants? In this one, it's Cl2 gaining electrons. So the reactant is Cl2. I can combine the two half equations together. Over here, the reactant is copper, so Cl2 and copper are my reactants. And what are the products that are forming? The products that are forming are over here, it's Cl minus 1 that's being formed. And in this one, it's copper 2 plus that's getting formed. So this is my overall reaction. So I figured out the overall reaction that's going to happen. Copper is going to react with chlorine to form copper 2 plus and Cl minus 1. What else? The other thing is the E0 cell. I don't know why this is 1.36. What's the E0 cell now in this case? It's going to be the potential difference. Higher potential minus lower potential. What do you get?
1.02.
So the E0 cell of this particular reaction comes out to be 1.02 volts, which is kind of higher than the last one. So that means the electrons would be this reaction would be kind of more vigorous compared to the last one because it has a higher potential difference. So the electrons would flow much faster compared to the last one that we did. So is this clear?
Yes, sir.
Okay, so this is all about electrochemistry. There's going to be one cell and there's going to be another cell. You connect them together, electrons flow towards the higher potential. The higher potential one is the one that's going to gain electrons. The lower potential is the one that's going to lose electrons. And you can just add up the reactants and you can add up the products of both sides, of both half reactions. Product is this, over here the product is this. But make sure the number of electrons lost and gained are equal. If they're not equal, you multiply both with a number to make that equal. So let's continue with the same thing tomorrow. Okay?
Okay.
Thank you.
Okay, take care.
Thank you.
Sir.
Allah Hafiz.
Allah Hafiz.